Hello, my name is Victor. With this video, I want to start a series, and in this series, I want to learn a programming language called Erlang. And this series is going to be very highly unstructured. Well, that's what I expect it to be because I don't know where it's going to go. I'm just going to learn something about it and make a video about it. So today we will just begin with what is Erlang. That's a good place to start. Now, Erlang was made in the early 80s. That's when development began. And it began in a company called Ericsson. So this is a Swedish telecom company. And they do stuff like they build hardware and equipment for telephone exchanges, for 3G, 4G, 5G, all these different kinds of networks. And so in the early 80s, what they really wanted to do was they wanted to build a system, the next generation of telecom systems really. And they were looking for certain characteristics in these systems. For example, they needed these systems to be highly fault tolerant, highly available. You couldn't afford to shut these systems down even for maybe a second, because that's a huge loss for businesses and for them, for them and for their customers. And and a lot of other things. These were distributed as well. So what they did was they started experimenting with several languages, actually more than 20 of them. And it was by the mid-80s. So this all started in the early 80s. And by the mid-80s, like 85, 84, they came to a small set of languages. The most notable of which were Prolog, Parlog, and Lisp. So what they said was, okay, with these languages we could kind of attempt to build the kind of systems that we're looking for. And so they continued their experiments, and then they found out that even these languages were lacking. Now, besides all the characteristics that they needed in these kind of systems, they were also looking for a language that provided them with certain things, and these certain things were primitives like concurrency and error handling. Now, obviously, if you have any experience with programming languages, you know that almost all languages provide you with some sort of concurrency and some sort of error handling. So the most famous examples are the try-catch block for error handling, and maybe in a language like Java you have classes for threads for processes. No, what they wanted was primitives. So if that isn't very clear, I'll try to explain it to you. Now, primitives are how you build a computer program. So for example, if you have any experience with computer programming, then you already know that every programming language allows you to create variables, to create functions, subroutines, whatever they're called. You have different types of values. You have strings, you have numbers, you have real numbers. So you have all these different primitives. So the primitives are how you build a computer program. You build it using variables, with loops, with different expressions. And they needed concurrency and error handling to be primitives in the language. So basically what they were saying was they need a language in which you just build with concurrency, where you build with error handling, right? So these programs, they have to have all these different things. And this is important because, like I said, these are distributed systems. These are systems that are always running. They have to be always running. And it makes sense for them to have concurrency and error handling as primitives. Now, obviously, these languages that they selected, Lisp, Prolog, Parlog, they didn't have them. They didn't have these characteristics. So they came to the conclusion that they had to make a language. So it's important to understand here that they never tried to make a language. What they were really trying to do was solve a problem, which was they were trying to build the next generation of telecom systems. And in the end, they found out that, there's nothing out there with which they could do that with the characteristics that they wanted. So they set out to build a language. So this was in the mid 80s, around 85, and that's when they started work on Erlang. Now, it was by somewhere between that time and the 90s that there was a very basic implementation of Erlang, and some people already started using it. So besides Ericsson, a few other companies were interested in this, and they were building PABX systems with it. So a PABX system is basically a telephone system that you might have seen in companies. So you don't actually so you can call people within a company, a company building. Another good example is hotels, and hotels basically. They have these, like for example, the reception and each individual room, so you can like call from any room to the reception and all that. So there were companies who were building these kind of systems using Erlang, and I think it was around 87 when this team at Ericsson. So I think I haven't mentioned the team. So the team at Ericsson was Joe Armstrong and a few other people. So Joe Armstrong is usually the name that comes up when we talk about Erlang and its history. So it wasn't just him who made it, it was a few other people involved. So they started to rewrite, well, I'm not sure if it was a rewrite, but they started to build Ericsson's MD110 system. So let me show you a picture of that. Well, it's not really a picture. I don't know if this is how it looks like. But so again, this is just like a PABX system. So this is something you deploy in an office, in a hotel, and to set up communications between different branches, between different departments, different rooms. So they started building this thing using Erlang, and they built only 1/10 of it. So they built only like 1/10 of it, and that itself, just the part that they rebuilt with Erlang was about 10 times faster than what it was compared to the previous implementation. And this was with a slow implementation of Erlang. So that's very interesting. So by the 90s, Erlang became a bit more mature. It became open source. And right now it's maintained by a group within Ericsson itself. And and there are like a lot of companies who use it. A really good example, the most relatable example, is WhatsApp. WhatsApp is built with Erlang. Now, it's because of the problem that they were trying to solve that makes Erlang such a good language that's for systems that design for systems like telecom switches and something distributed, something fault tolerant, something that's real time, highly available and maintainable. So this is the Wikipedia page, and it mentions that you can do hot swapping. So this is when you have a running system and you don't stop it, but you can go into that running system and change the code, and this is really useful and really important for systems like this. So imagine that you have a telephone switch. There are hundreds, thousands of phone calls going through that right now. You obviously can't stop that. I mean, there could be many important phone calls going on right now. You can't stop that system, but you have to fix it. So you can do that with Erlang, and it's really interesting. So that's a bit of the history. So let's get back to our actual question. So what is it? So we know that from the history, we know what it was made for, what it was built to solve, and it's really good at that. So it's used in WhatsApp, it's used by Amazon, it's used by a lot of people for systems with these kind of requirements, and there are a lot of them. And the reason is that Erlang is not just a language, it's really an ecosystem. So I found this really nice picture that explains, that highlights this. So the language, this red section, that's just a part of it, the whole Erlang system. Now Erlang is compiled and it's also interpreted. So it's compiled down to some bytecode, which is run on a virtual machine called the Beam virtual machine. And the Beam virtual machine is really the reason why Erlang is so good at building those kind of systems. And besides those two, the virtual machine and the language itself, you have the standard library, which is called the OTP, the Open Telecom Platform. Okay, this was initially built to solve Ericsson's problem, right? They're a telephone company. So this is Erlang. It's an ecosystem. It consists of a language, a virtual machine, and a standard library. And it's really, really good at building applications that are fault tolerant, highly available, distributed. So how does it do all that? It goes back to some ideas back then. Now, if you have done any programming before, then you most probably have come across processes, threads. Now, Erlang also has processes, but these are not the same as the kinds of processes that operating systems make for you. Now, the processes in Erlang are very, very lightweight, in the sense that it doesn't take so much a CPU and memory to manage them or make them. They're cheap, so you can make thousands of them, or even hundreds of thousands. And the philosophy of Erlang and building programs with Erlang, as far as I know right now, is you write something, if it runs, it runs. If it doesn't, just let it die. You just let it crash, It'll be handled later, just let your program crash. So if your program just crashes, how does anything work? It's because of how these Erlang processes are combined to build the whole larger system. Now, a great way to describe this is you have a system, right? So a system is basically all these small processes. I'll give a concrete example of this in a bit. So these processes, these are like small programs, right? That are always running. They may fail, they may not fail. They may know about each other's existence. They may talk with each other. So that's the whole system. And if one of them fails, it's no problem, right? The system as a whole just keeps moving forward. So I'll try to exemplify that. Think about telephones. Think about the whole telephone network. Let's say that you're on a phone call with your friend, right? You're talking about something, but something goes wrong and the phone call is disconnected. Sure, I mean, that's a bit annoying, but all you have to do is you just have to call back and you just continue where you left off. Now imagine that you're in a phone call with your friend and someone else is also talking. Obviously, obviously hundreds and thousands of people are talking. But let's say that something goes wrong in somebody else's this call session. Now, does it make sense for your phone call to be disconnected because somebody else's session something went wrong with it? No, it doesn't. So, in Erlang, you would launch a process just for that one phone call, right? So that single phone call represents that session between these two people, they're talking to each other. If something goes wrong with it, that process dies. And all these other processes, all these other phone calls, they're unaffected because they're their own thing. So that's how you have this system of many small processes. And if one of them dies, there's no problem. I mean, sure, it's a bad thing that it died, but the others aren't affected. The system as a whole just moves forward. So that's Erlang. And that's how it's able to achieve, that's how it's able to achieve these things, building systems that are fault tolerant, highly available, concurrent. So that's it for this video. Yes, that's it for this video. So I hope you enjoyed this, and this is the first time I'm ever using my webcam. I'm actually recording myself like this. So, not very polished. So I hope you enjoyed this. Please consider hitting like on this video and subscribing. And I'll see you next time.